Okay, this is section 9.5 in the textbook, and this has to do with polar covalent bonds. I'll kind of go off to the side there. A polar covalent bond is when the bonding electrons spend more time around one atom than they do the other. So what I have here is three examples. I have hydrogen-hydrogen, which is a nonpolar covalent bond, and the electrons are shared evenly between the two hydrogens. Okay, and this is a heat map here showing time spent. I have hydrogen chloride, which is a polar covalent bond. So the red means that the electrons, this is more negative, this is more positive because there's actually no electrons over here, but the electrons spend more time around the chlorine atom than they do the hydrogen atom. Whereas ionic, which we've discussed already, this electron has been given up and been given to the chloride. And so that's what's shown here, is there's no sharing of the electrons at all in an ionic compound. So how do I tell if something is ionic? Okay, good spot for this. All right, so basically it's dependent on the electronegativity. Electronegativity is the desire or the ability of an atom to move, an atom in a molecule to draw the bonding electron to itself. Okay, so basically you can think of it as being likability. Okay, in general, electronegativity increases from left to right, so that's shown here. So as I go across, let's choose this row here, 0.9, 1.2, 1.5, 1.8, 2.1, 2.5, and 3.0. So as I go across the row from left to right, it increases. And as I go, it also increases from the top of the periodic table, or sorry, from the bottom of this periodic table to the top of the periodic table, it also increases. So this is showing decreasing as I go down the column. Okay, so you'll notice that this basically follows the same thing as the size of atomic size. Now, of course, the noble gases are not shown on this because the noble gases neither want to gain an electron nor do they want to give up an electron. So they're not shown on here. So fluorine is the most electronegative element that exists. Okay. Metals and nonmetals tend to have a large difference in electronegativity. That's why they become ionic. So at about a difference of about 2.5, and it's not a set number, but it's approximately 2.5, between 2 and 2.5, is when it goes from being a polar covalent bond to being an ionic bond. Okay, and the electrons are always drawn towards the most electronegative atom. Okay. So, with the aid of the periodic table, arrange the following in order of increasing electronegativity. So this is 56 in the textbook. Lithium, sodium, and cesium. So what I have done is I have highlighted those in red. Okay, so you can see that they're all in one column on the periodic table here. So which one of these is the least electronegative, since it's wanting an increasing electronegativity? And the answer to that is cesium, followed by sodium, followed by lithium. So the answer to that one is cesium, sodium, and lithium. For the next one, the two elements overlap, so lithium overlaps, so I put a new periodic table on here. I've highlighted lithium, barium, beryllium, and boron in blue this time, okay? And so this time they're all on a single row. And so if I go from left to right, does it increase or decrease? The answer is increase. So therefore, lithium is going to have the lowest, followed by beryllium, followed by boron. And so that's the order of that one. And for C, I have sulfur, selenium, and chlorine. And I highlighted those in green. Put the image down a little bit more. So they're right here. This is selenium, that's sulfur, and that's chlorine. And this one's a little bit more difficult because there's both a row and a column in here. Okay, but chlorine is the most electronegative because it's the furthest to the right and the highest up. Between sulfur and selenium, sulfur is more than selenium. So the lowest is selenium, followed by sulfur, followed by chlorine. And why is it not showing up? There you go. And there's the selenium, sulfur, and chlorine. And so that's the end of this section here.